welcome to study. Welcome back to our channel again. Now, we're going to continue our GEP preparation for round 1. So today, our topic will be on the logic reasoning. So let us take a look at this question together. Now, this is a question from the 2024 GEP round 1. So it's a real question. So we got 7 number cards with the number 2, 3, 4, 6, 7, 8, and 9. Now, Alex picks up 2 cards. Product of the 2 cards is 12. Ben picks up 2 cards. Sum of the 2 cards is a multiple of 6. And Cindy picks up 2 cards. Difference of the 2 cards is 2. They're asking, what's the number of the last card? So let's think. Now, in this question, we got a lot of different cases here. Right? For Alex, we got different choices. Right? If the product is 12, we can do 2 and 6 or 3 and 4. The same for Cindy. Difference is 2. Of course, we can try 9 minus 7 equal to 2. Or we can do 4 minus 2 equal to 2. So how do we start here? Do we just do guess and check? Now, if we do guess and check, if we are lucky enough, we'll get the answer directly. But sometimes, if we are not lucky enough, we'll get repeated numbers here. Right? For the Alex and Cindy, you might choose the same number. So this way, it will be wrong. Because out of the 7 number cards, we must choose 6 different cards here. So the thing we need to think, what are the possible choices? So let's figure out the numbers together. Now for Alex, product of the 2 cards is 12. So just now we already discussed, it can be 2 times 6 equal to 12. Or it can be 3 times 4 equal to 12. Now for Ben, the sum of the number is a multiple of 6. So everyone, what are multiples of 6? We know that multiple of 6 is by using 6 times another whole number. For example, we can do 6 times 1 equal to 6. That's a multiple of 6. Or we can do 6 times 2 equal to 12. That's also a multiple of 6. Or we can do 6 times 3, 6 times 4, 6 times 5, so on and so forth. So let's list down the first few multiples of 6. We got 6, 12, and 18. So let's see which of them works. Now, if the sum equal to 6, what can be the possible numbers? Can we do 1 and 5? Of course we cannot do 1 and 5, everyone. Because of 1 and 5 are not even given in the question. So we can do 2 and 4. 2 plus 4 equal to 6. So the next thing we need to consider, can we choose 3 plus 3 equal to 6? Some of you may say yes, some of you may say no. So this one we must take note. We must choose 2 different cards. The same card cannot be chosen 2 times. So for sum equal to 6, there's only 1 choice here. Now, if the sum equals to 12, what are the possible numbers? If we choose 2, we must also choose 10. But 10 is not given, so this one cannot. So if we choose 3, we can also choose 9. 3 plus 9 equal to 12. So that's one of the number. Now, if we choose 4, what's the other number? Very good, everyone. The other number is 8. 4 plus 8 equal to 12. So now, can we choose 6 plus 6? We all know that now we cannot choose 6 plus 6. Just like we cannot choose 3 plus 3. No repeated cards. Now, the last case, sum equals to 18. Is it possible? Just now we know that we cannot choose repeated cards. So it cannot be 9 plus 9. So this means that even if you choose the largest card here, 8 and 9, 8 plus 9 is 17. That's too small. So this one is not possible. Now, if this is not even possible, we don't have to check for bigger numbers anymore. So let's move on to Cindy. Difference of the 2 cards is 2. Let's check. Out of these numbers here, which one gives us a difference of 2? The first we can see, 4 minus 2 is equal to 2. What else? Very good, everyone. 6 minus 4 equal to 2. What else? Perfect. We can also do 8 minus 6 equal to 2. And lastly, we have 9 minus 7 equal to 2. So now we figure out all the possible numbers for Alex, Ben, and Cindy. Let's list them down nicely. Right? So notice that Alex got 2 choices. Ben got 3 choices. Cindy got 4 choices. The next thing we need to think. Where should we start? Should we start from A, B, or C? So notice that if, let's say we start from C, we have to discuss them separately. If Cindy is 2 and 4, then we check for Alex and Ben. If Cindy is 4 and 6, we check for Alex and Ben. If Cindy is 6 and 8, we check for Alex and Ben. If Cindy is 7 and 9, we check for Alex and Ben. We got 4 separate cases here. But if you choose A instead, what's going to happen? Oh, we notice there are only 2 cases. This one is much easier. Only need to discuss 2 cases instead of 4 cases. So that's why we're going to start from A here. So we can have least amount of workings here. So for Alex, if we choose 2 and 6, now can we choose the number 2 and 6 again? Definitely we cannot choose them again. So for Ben, we have to cancel those that contain 2 or 6. You look at the choices for Ben. 2 and 4, this one cannot be used because it contains the number 2. Now, the others do not contain 2 or 6, so we move on to Cindy. Now, for Cindy, those that contain 2 or 4 cannot be used. So we have 2 and 4, 4 and 6, 6 and 8. Those cannot be used. Now, everyone, you notice that one thing here is that if you continue with Ben, we still have to discuss two cases. Ben can be 3 and 9, or Ben can be 4 and 8. But how about Cindy? Oh, everyone, we notice that for Cindy, there's only 1 case left here. So the number is already fixed. There's nothing else we need to discuss for Cindy. So Cindy is just 7 and 9. We'll just jump to Cindy directly, since there's nothing to discuss here. Now, if we choose 7 and 9 for Cindy, how about Ben? Teacher, we notice that we cannot choose the 9 again. So 3 and 9 is out. We only got 1 case left. This will be 4 and 8. We've got all the different numbers for the A, B, and C. So now let's check what's the last card. The last card will be the number 3. 3 is left. So are we done with the question? Everyone, not yet. We must discuss the other cases because the other one, it might also be correct. So let's check. Now, for Alex, instead of choosing 2 and 6, we can also choose 3 and 4. Then we just do the same method again. We do the elimination method. If the number is used, it cannot be used again. So 3 and 4. We check for B. Everyone, we notice that one thing we have is everything contains 4 or 3. You see 2 and 4 contains 4. 3 and 9 contains 3. 4 and 8, this contains 4. So it either contains 3 or 4, means everything cannot be used here. So we got no choice left for B. B, we must put a cross. Nothing left means that this case is wrong. We cannot solve here. So the final answer, the last card left, is the number 3. Now, let us do a quick summary on this question here. So in this logic reasoning questions, because we got so many conditions, so we must list down all the possible cases first. Now, after we list down all the possible cases, we will discuss them case by case. Now, this way, we won't miss out any of them, and some of them might just be the correct answer. That's why we do not just do random guess and check here and run, so you must take note of that. Now, when we discuss them case by case, there's another thing we need to take note. Did we start from A or C just now? Oh, we started from A. The reason is because for A, we got 2 cases. For C, we got 4 cases. So you always start from the one with least number of cases. This way, we do the least amount of workings here. The last thing is, when we discuss them, we use the method of elimination. Those numbers that's not possible, you just put a cross there, means the number cannot be used. So now, after we are clear about the summary, I give you this practice question. It's very similar to the question just now. Now, once you figure the answer, you can send your answer in the comment section, or else you can contact me directly. You can add my WeChat or WhatsApp, so we can discuss the solutions together. Now, if you want to get more updated information on our activities for GP preparation, you can join our study groups here. You can just simply scan the QR code and join the WeChat or WhatsApp group. So now, if you want to receive more awesome videos from our channel and you don't want to miss out any more learning points, make sure to subscribe to our channel and hit the like button. So until the next time, peace out.